Let's look now at creating functions in Python. So by definition, a function is just a set of code which will run when we invoke that code through the function name. So here's a very simple example of that. We are creating a function called adder, and that function will receive two arguments, a and b, and the function is going to send out, it's going to return to us the sum of a and b. So this is the basic syntax for the creation of a function. We use def, I guess, for define. So we define and then we provide the name of the function, and then we provide a list of arguments in the parentheses. And then we use a colon to signify that the lines which follow will belong to that function. And the lines which follow must be indented. So we may have multi-line functions, so we may perform other operations in here. For instance, we may define another variable and whatever other operations we like in here. So we are not restricted in any way by the size of the block, but it must all remain indented, and then we have a return at the end which will provide us with the output from that function. A function doesn't necessarily have an output. For instance, if a function is just used to print something to the screen, then it may not be necessary to return a value as well. So in this code block, we are looking at the definition of this function, and then we regard this part as being out of that code block. So here we are defining the function. Everything above and including this line containing the return is part of the function. And down here we are making use of this function. So we are basically running our function. We are calling the function. We invoke the function through the name. So we use the name there, and then we pass it the two arguments that it expects. So here we are specifying values for the two arguments of that function. So we pass in the two arguments, all these operations run, and the function will return this value, which is the sum of these two arguments. These will run, but you see they do not influence anything, and they do not affect the final result. It's important to note also that the variables that are used here do not exist outside of the scope of this function. So, for instance, if we were to attempt to print the value of c, even though that is defined in the function, out of the function, that value for c is no longer defined. So if we run this, we get the error message, c is not defined, and that's because that's not inside of this function. So removing that, when we run this, we can see this function is doing what we expect it to do. It is simply adding together the value of 10 and 20 and giving us out a 30. So that's the very basic syntax for a function and its definition. Now, the next useful thing is that we can pass functions in the argument space to other functions. And in a way, we are already seeing this here. So we defined this function adder, and then we are using adder in the argument space of a different function. So the print function, which is built in Python, we are passing into the argument of print this statement, and in a way we are passing in only the result of this operation. We aren't passing the function itself. So when this part of the statement runs, this is going to return for us a single value, which is a plus b. And so this highlighted line of text is actually going to evaluate to a number, and then that's just the printing of that number. We aren't actually passing a function into a function here. However, that is allowed. You can do that. So you can pass a function into another function. So once more, we've defined the function adder up here, and down here we are creating a new function. So we've defined this function run n, which is going to take some arbitrary function in here, and it's going to accept a second argument, which is a value n. And according to our definition of this function, we create a for loop, which is going to run from 1 to 5. And inside of that for loop, it's going to print out whatever that function is. So it's going to evaluate this function using the arguments n, where n is the second argument to run n, and I, which is going to be the set of values between 1 and 5. And so we can go ahead and run this by typing in run n, and we are now using the function we defined earlier. So up here we've defined adder, and we pass that as the first argument to this function, and we pass in a second value. So we provide a value of 3 for n. And so we expect that when this runs, it's going to evaluate func, and func is of course adder. So adder is going to receive a value of 3, and then it will receive a value of 1, and then a value of 2, 3, 4, 5. So it's going to be 3 plus 1, 2, 3, 4, 5. And there's the result, 3 plus 1, 2, 3, 4. And of course, I said it incorrectly there. When we run the for loop over that range, it runs from the first value up till and excluding the last value. So this is an example of passing a function into the argument space of another function. So that is permissible. You can almost treat a function as a variable where we have assigned, we've passed that function almost as a variable into the argument space of this other function. So that's one useful thing, especially if you are involved in functional programming. There are many powerful things you can do when this is possible. Another useful thing we can do is specify default values in our argument space. So here we are defining a different function, and it has two arguments, a and b, and we are returning this time the product of those two numbers. However, we have the strange syntax here where we seem to be assigning a value to a and to b, and that's during the definition of the arguments of this function. And what we are doing there is simply specifying default values for the arguments. And here's an example where we are calling on the function, but we aren't passing any arguments to that function. So when we do it that way, the compiler is going to look at the call, and it finds no arguments there. However, because this function was created to have those defaults, then it will use those numbers for those arguments. So if we run this, you can see the value of 20. So that's 10 times 2. Of course, if we go and change this here, so let's say we specify a 3. So now a has taken on a value of 3, and then b is a 2. So we should get a 6 here. And there's the result. I haven't really tried this, but I'd like to see if we don't specify a number here. Well, that's a syntax error. We can't just leave it blank like that. So we are able to specify an override value. We can think of this as overriding the default value. So we've overridden a value of 10. It's now 3. And let's override the other value as well. Let's say b is 12 instead. And we can see we get the expected result. So that's providing default values for the arguments of a function. Another useful thing we can do is to, in the calling of the function, it's quite useful for us to provide the name. It might be that we've specified a function and we've forgotten the order of the arguments that we've provided. So we can instead specify which values we intend to assign to which arguments, even though we can't recall the order of those arguments. And it's not just about our recollection. It may also be that we want to make our code more readable. And for sure, this is more readable. We can see here we intend for these numbers to have these values. So let's test this. We've defined here a function which accepts two arguments, a and b. It prints a dividing line, and then it prints a first and prints b second. So if we run it with 10 and 20, you can see we get 10 and 20 as expected. If we reverse the order, if we make it 20 and 10, then yes, we get 20 and 10. But let's say we had only specified 20 and 10 because we couldn't recall which was supposed to be A and which B. Then we would fix that by saying, well, I can't remember which argument goes where, but what I'll do then is just specify the name of the variable that I intend that 20 to be. And so we say here B equals 20 and A equals 10. And now we can see A is 10 is printed first, so it's accepted A for that value of 10 and B for that value. So an argument doesn't have to be positional only. That's the default operation. But by specifying the names of the arguments, we can override the positioning of that argument space. The other useful thing we can do for the arguments is specify a variable number of arguments. So if we would like to create a function which is intended to be quite general, so general to the extent that we may have multiple arguments where we don't want to specify how many arguments that is. And you can think of simple applications of that idea, for example, in the plot command. So quite often when we plot out a figure, we want to specify more than one curve on that plot, and we don't want to fix the maximum number of curves, or we don't want to have to specify separately how many times we want to create curves on our figure. So to do that, when we define our function, we prefix the name of the variable with a star, and then we can determine the number of arguments that enter the function using this len. And if we print that out, we of course this is just to test it, we can print out and look at how many arguments we get there. So in this example, we are calling this function with this variable argument style. We are first calling it with 3 arguments, and then we go on to call it again with 5 arguments. And I just want to put a separator in here because we are calling that twice, and let's run that. So you can see the first time this function runs, we have 3 arguments. So in here, we are told, yes, there are 3 arguments. And then the second time, it's going to print us the list of all the arguments that we have available. So we can see there the 3 arguments. So that's all come from this first call of that function. And then here we call the function with 5 arguments instead. And now you can see the update showing that, yes, there are 5 arguments. And when we print that, it shows us what those 5 arguments are. Another example of this useful style of things is in our adder function. So in our original definition, we could add just 2 numbers together. Well, what if we wanted to specify any list of numbers, or what if we wanted the trivial case of a single number? So we can specify now a single number. We are using variable arguments, and we are looking for the sum across all those arguments. And so for a single number that works. If we use 2 numbers instead, that also works. And then we can use any number of arguments, whatever, and we get the result there. So that's using a variable number of arguments. So be sure that the basic syntax of creating a function is well absorbed, and all these other variants really help us to increase the power and the usefulness of our code.